Welcome to the webinar on the EICASLAB demo real-time embedded for Beagle Bone Black board. This demo is called the real-time embedded because it is a real-time demonstration on an embedded system. It demonstrates through a complete control design development how all the control design phases are carried out with just one software suite, but also working on just one EICASLAB project. It allows the user to experiment the target mode on a popular embedded board, such as Beagle Bone Black board or Raspberry Pi. All the control design phases are managed by the EICASLAB operative modes. The modeling and like real-time simulation mode allows to design the overall control algorithm and to test it in a simulated environment through like real-time simulations. Then, the Rapid Control Prototyping operative mode allows to validate the same control code already tested in modeling and like real-time simulation working with the real plant. It has two sub-modes: the RCP on field, in which the control is executed in real-time piloting the real plant, and the slow motion, that allows an offline repetition of the trials recorded on RCP on field for debugging and tuning purposes. Finally, in the target mode, EICASLAB automatically generates the code to be transferred to the final target and enables to perform hardware-in-the-loop test, working with the target and the simulated plant, and final validation test that allows to monitor the final target hardware that pilots the real plant. For performing all the control design phases, you need, first of all, a PC, which is a standard multi-core PC equipped with a real-time operative system and suitable hardware interfaces, which we will call EICASLAB RPC Platform, in which the EICASLAB suite runs and with which you can develop the control in an easy-to-use, seamless and low-cost way. For the last phases, in order to validate all the control strategy, you need the real plant and the hardware target. The plant we will consider is a rotating table. The demo provides a complete example of control design of a rotating table, from the simulation to the download to the final target. The rotating table is a classical and significant example of control. It is a load rotated by means of an electric motor through a mechanical gear. The motor rotation angle and the load rotation angle are measured by two encoders. For more technical details about the control of the rotating table, you can refer to the document Rotating Table Test Cases of the EICASLAB demo in the EICASLAB website. The aim of the control is to make the rotating table follow some specific trajectories. We consider two types of trajectories. In the first case, that we indicate as point-to-point mode, the control system is required to rotate the load from the current angular position to a new commanded angular position, and the rotation must be carried out in the minimum time within constraints on the ranges of current acceleration and rate. In the second case, that we indicate as tracking mode, the control system has to track given reference trajectories, which must have angular rate, acceleration and frequency bandwidth within fixed ranges. We consider a perturbing torque acting on the load with a low frequency component of given amplitude and a given random frequency component. As previously described, rapid control prototyping and final validation test should be carried out working with the real plant. But to enable the user to work without the need of the real plant, this demo provides a rotating table emulator, which replaces the real plant. There are two different versions of the demo. The first is dedicated to the Beagle Bone Black embedded board, and the second is for a generic Linux target such as a Raspberry Pi. This webinar presents the first one. This demo has minimum requirements on both the PC running EICASLAB and the target embedded system. For the real-time performance requested in the real-time operative modes, we recommend to run the demo in Linux operative system with a preempt RT kernel, though some modern PC may provide good real-time performance even without the preempt RT patch. More information and configuration hints are given in the demo user manual. The PC also needs networking interface to connect to the target. The demo has been tested on Beagle Bone Black revision C, but you can use another board compatible with these requirements.